Hey everyone, I am Nitij, and in today's video, we are going to build a simple load balancer in Node.js. We will explore how to effectively distribute web traffic using round robin and least connections algorithms. And this project is perfect for those who are looking to deepen their understanding of server management and Node.js capabilities while implementing a simple load balancer. So as I have already mentioned, we will be using Node.js to handle the incoming server requests. Alongside Node.js, we are utilizing the HTTP proxy library for creating our proxy server, which is central to our load balancing logic. And we will manage our server configuration with a JSON file, ensuring our setup is both flexible and easy to modify. Also, please be aware that the load balancer we are going to build in this video is intended for educational and demonstration purposes only. While it may provide a fundamental understanding of how load balancing works and how to implement basic algorithms, this solution is not production ready. Alright, so without wasting any more time, let's get started with building our load balancer. This is Visual Studio Code, and the first thing I will do over here is to create a new node application. That can be done by simply executing the command npm init with the y flag to say yes to every question. I will also install two dependencies by simply calling npm install, and the dependencies are http and http proxy. Alright, now it's time to create our backend files. The first file that I am going to create is to create our backend servers. So let's name it as backend servers.js. Now this file will serve the purpose of simulating a bunch of backend servers to which our load balancer can route the incoming requests based on the algorithm that we are using. So we will be using HTTP to create the server. Now to create the individual servers, I am going to create a function with the name create server. So this function is going to accept the arguments for the host name and the port number. So this is going to be the function body. Inside create server functions body, first we will call http.createServer, and then we will provide a callback function which is going to accept the arguments for request and response. So from this function we will simply write to the response the status code, which is going to be 200, which is going to indicate that this is a valid response, and then we will simply write response.end with a message. So let's use a template string over here. So server response from, and then we will simply provide the port number to get to know from which backend server we are getting this response. So from port and then $port. Next, we may want to know when this server has started running on the provided host and the port. So for that I will simply chain a listen command over here, and the listen command is going to accept the port and the host values, and then a callback function which is going to be called when the server will start to listen. For that I will simply log to the console a message which will say server running at, and then HTTP. So first there will be the host name, and then there will be the port number. So host and then port. Our function to create individual backend server is ready, and now to create the individual servers we can simply call create server, and then we have to provide the host name. For example, we can use localhost for this tutorial, and then for the port number we can start from 3001, and then we can go all the way up to the required number of backend servers, so 3002, 3003, 3004 and so on. But this is not a very helpful way to create servers, because our main load balancing server will also need to know how many backend servers are running. Now in any production grade load balancer, there are separate mechanisms for the load balancer to know which services or which backend servers are running, such as service discovery mechanism. But for this simple example, we are just going to create a JSON file which is going to be shared across the backend servers file and our main load balancer. So for that I am going to remove these 4 statements from over here, and then let's create a new file with the name config.json. Now in config.json we are simply going to write the JSON structure for our servers configuration. So hold on, servers, and then this is going to be an array. Each array is going to contain a single object for the individual backend server configuration. So first we have to provide the host name. So host name can be localhost. We have to provide the double inverted commas because this is a JSON format. And then for the port number, I am going to provide 3001. Okay, now let's copy and paste this 4 more times. So 3002, 3003, and then 3004. Okay, so this is our server configuration. Now let's get back to our backend servers.js file. Over here we can simply import this server config. So const server config equals to require, and then we have to give the path. So path is, hold on, dot slash and then config.json, and then we can simply fetch the values of this servers property, this one, servers. So dot servers. Now we can simply iterate over the collection of servers we have fetched from our server config file. So server config dot for each, and then for each server we are simply going to call create server, and then we are going to provide the server dot host as a value, and then server dot port as a value. And yeah, that's pretty much everything we need to do. Now let's first test if our backend servers are being created or not. For that I will open up a new terminal, and then let's run the command node and then backend servers. So it says server running at http localhost 3001 all the way up to 3004. So our backend servers are running. So now it's time to move on to our individual algorithms that we are going to implement for the load balancer. First, let's implement the simplest algorithm, which is the round robin algorithm. So round robin simply means that the load balancer is going to always pick the next server in line to serve the incoming request. So I will show you how that happens or how that can be done. So first let's create a new file with the name not robin, actually round robin.js. First we are going to import the HTTP proxy to create our proxy server. So this can be done by simply importing its dependency, and then we are going to create a proxy. So this can be done by calling http proxy dot create proxy server, and then we are not going to provide any options for our server. Now to track which is the current backend server the round robin algorithm needs to request, we simply create a variable with the name current. So current's default value is going to be 0, which will indicate that it needs to start from the first server. Now for round robin we will simply create a function with the name round robin, and this is going to accept 3 arguments. The first one is going to be the list of the servers which the round robin algorithm can use. The second one is going to be the request, and then the third one is going to be the response. So first we need to know which target server the round robin scheduling algorithm needs to use. For that we can simply create a const target equals to servers, and then we can fetch the server to use based on the index, so like 0, 1, 2, and remember that we created the current variable to track the current index, so we will simply use current over here. Let's also log to the console the target server which has been picked up, so console.log and then target. Now when the target server has been chosen, we can simply implement the value of current. So current equals to current plus 1, but we have to make sure that it will not be more than this server.length, so we will simply write % and then servers.length. Finally we simply need to proxy the request to the target server, so proxy dot web, and then we have to provide the request and response as the arguments, and then we have to provide the target URL for our target server. So this can be done by simply providing this options object and then the target property. So hold on, the URL is going to be HTTP. So we have to provide the host and the port values, and that can be found by referencing the host and the port properties from the target server. So let's do that. So target.host and then target.port. All right, now let's finally just export the round robin function so that it can be used as a module from our load balancer. So module.exports equals to round robin. Let's save it, and now it's time to create our main load balancer file, which is going to be the server.js. In the server.js, we are going to import a bunch of dependencies first. We are going to need the HTTP package to create our load balancer server, and then we will be importing the round robin algorithm. So round robin equals to require, and then let's give the path, so / and then round robin. We will also need to import this server config, so const server config. This import is going to be the same that we have done in the backend servers file. So server config equals to require and then / config.json and then .servers. Next, we need to initialize this servers array that our load balancer algorithms are going to use. So const servers equals to server config.map, and then for each server we are just going to return a new object by simply spreading out the existing server properties. So .. and then server. Now you must be thinking that why aren't we using these servers array directly? Well, let's do this for now because later we will need to modify this code anyways for our least connections algorithm. Next, let's create a constant for the load balancing algorithm to use. So load balancing algorithm equals to let's use the round robin because this is the only one that we have available right now. Let me remove this space. So round robin. All right, now let's create our load balancer server. So const server equals to http dot create server, and then again this is going to accept the callback function with the arguments of request and response. First, let's add the condition to check the load balancer algorithm that we need to use. And hold on, why is this showing an error? Okay, this needs to be named as servers, not server. All right, so let's first check what load balancing algorithm we need to use. So if load balancing algorithm is round robin, then we are simply going to round robin each request. So round robin and then servers request and response. Let's also give a fallback message if the load balancing algorithm that is provided is not supported. So if that's the case, then simply write to the response response.write head with the status code of 500, and then response.end by simply saying load balancing algorithm is not supported. Finally, let's start to listen on the server. So server dot listen on port 3000, and then callback function to simply print to the console that the load balancer server has started running on port 3000. All right, so this is everything we need to do for our main load balancer server. Now let's create a new terminal and then run our server file as well. So node server, it says load balancer running on port 3000. Now how do we test our simple load balancer? We cannot do that by using browsers because there is a limit to how many connections a browser can open to the same target, and then if there are any delays from any of the backend servers, then the browser will simply not going to accept a new request. So let's do something else. Let's use the curl command to test our load balancing servers. For that, I will first create a new shell script and I will simply name it as test_load_ balancer. And I also have to provide the .sh extension as well. Now in this script, I will simply add the code to send out a bunch of different requests all together to our load balancer, and we can control how many requests we can send. So this is the code that we are going to use. Next, we have to make this script as executable, so that can be done by simply running the command chmod with our script file name in the terminal. So let's do that. Now let's run this script and test our load balancer's round robin algorithm. So it looks like we have an error while we try to run our load balancer. So let's see what is wrong over here. Received type number 200. So it should be related to the status code that we are returning from our backend servers file. So the problem that we are facing is because we need to use write head to return the status code. So write head, and now let's save it. Okay, now first let's run the backend servers again, and then the load balancer server, and let's run our script again. This time there are a bunch of different server responses based on the request, and let's check what has been logged in our main load balancer terminal. So load balancer running on port 3000, and then first 3001 backend server was invoked for our request, and then 3002, 3 and 4, and then 1 2 3 4, and then 1 2. So you can see that the servers which are being used by our load balancer are being called in a sequential manner, exactly how we wanted to do using our round robin algorithm. Now you have seen how round robin works. Now let's check out another algorithm that we can use, which is the least connections algorithm. So least connections simply work on finding the first server which has the least number of connections and then routing the request to that server. Now to implement the least connections algorithm, I am going to create a new file with the name least connections.js. Okay, so before we implement least connections.js, I'm going to introduce a change to our backend servers.js file. So over here, instead of directly returning the response, we will be using the set timeout functions to introduce a delay before a response can be sent. So instead of directly writing the 200 response and sending this message, this is going to be done by using set timeout, by using a timeout value, and the timeout can be provided as an argument for this function. So timeout, but because there is no timeout provided with this server configuration, we have to add the timeout property to our server config as well. So I'm going to add a timeout property to each of the backend servers that we have added, but let's use different timeout values. So for instance, 500, 800, 200, and then 300. Let's get back to our backend servers file, and we have to provide a third argument, which is server.timeout. Okay, now let's get back to our least connections.js file, and over here I am just going to first copy the code which is already there in the round robin, and then we will make changes to this algorithm to support our least connections algorithm changes. So let's first rename it to least connections and then export it as well. So instead of maintaining a current head, we are simply first going to sort the servers to get to know which server has the least number of connections. So that can be done by simply sorting this server's argument. So servers.sort, and then this is the sorting function that we are using, which is going to sort in the ascending order based on the connections property value. Next, to get the target server, we will simply use the first item in this sorted server array because it is going to have the least number of connections. When we have selected the server, then we can simply increment the target server's connections by 1, and then let's again log to the console the target server, and let's remove this logic to increment the current head because we don't need that over here. And this proxy.web is going to stay here because we still need to route the request to the target server that we have selected, but we need to do something else over here. So when the response is finished, then we will simply decrement or decrease the number of connections that the target server has because the response has already finished. So response.on finish, and then when this will happen, then we are going to call a callback function. So target dot connections minus minus to simply decrement it by 1. And there is one more change that we need to introduce to our load balancer server file, and that is to initialize our servers array with a connections property as well. So let's just add a new connections property, so connections with a value of 0. We also need to update this if else conditional logic so that our load balancer server is going to be able to use the least connections algorithm when it needs to. So for that I will simply copy this if condition. So else if load balancing algorithm is going to be, if it's going to be least connections, then we are going to use least connections. So let's import that as well. So least connections equals to require and then dot slash least connections. So let's use least connections over here, and let's set the value of least connections in this const load balancing algorithm as well. And I think that is pretty much everything we need to do to test least connections. Now let's save it and then open up the terminal. First I will run the backend servers again, and then I will run our load balancer server. So and then finally let's run our script to test the load balancers. Alright, so this time it seems that our load balancer is running the backend servers based on the number of connections that they have. So you can see that first it is running 3001, 2, 3 and 4, and then it is again running 4 and 3, and the number of connections are also displayed over here. Now you can play with the timeout settings for each of the individual backend servers to do a more comprehensive and accurate testing for your least connections algorithm. But this is how this algorithm is going to work, and that is based on selecting the server having the least number of open connections. So in a production environment, load balancing requires a robust setup to handle high traffic, to ensure security and manage failovers and provide consistent performance. Professional grade load balancers often come with advanced features like SSL termination, DDoS protection, health checks, session persistence, and many more things. For real-world applications, you should consider using any established load balancing solutions like Nginx, HAProxy, or cloud-based services such as provided by AWS or Azure. I hope you found this tutorial helpful and gained valuable insights. If you think you enjoyed this video and learned something new, then please hit the subscribe button. It really supports me and helps me bring more content like this to you guys. Thanks for watching and stay tuned for more coding tutorials.